We all know that all substances have mainly three states. They are solid, liquid, and gas. Beyond this, there is also another state called plasma. Notice some of the specialities of gaseous state. Molecules move randomly. Molecules move quickly and are free to move in any direction, spreading out long distances. Gases do not have a definite shape or volume. See the balloons rising upwards. This is because they are filled with gases which are less dense than air. Since the molecules in solid states are closely packed, the force of attraction is very high. Since the molecules are loosely bound in liquids and gases, the force of attraction is less. Suppose we take some water in a vessel and cover it with a glass plate. If it is kept for some time like this, we can see droplets of water on the bottom of glass plates. This process is called evaporation. Evaporation does not take place only in a particular temperature. But as temperature increases, the rate of evaporation increases. See some of the examples of evaporation. Wet clothes dry faster in hot seasons when compared to cold seasons. We sweat a lot in hot climates. Water in mud pots cools faster in summer. Water in wells and rivers dry up faster in summer. Gases do not have definite volume. Volume of gas will be the volume of its container. The unit of volume is cubic centimeter. See the burning incense stick kept at one corner of a closed room. The fragrance and smoke spread to other parts of the room also. This is due to the ability of gases to spread. This ability of gases to spread around is called diffusion. The reason for diffusion is the ability of the molecules to move freely in gaseous state. But diffusion is not that much possible in solid and liquid state. Notice the gaseous molecules kept closed in a vessel. These molecules move in all directions. When these molecules hit any surface during their random movement, they exert a force in unit area. This is called gaseous pressure. Pressure equals force by area. Commonly, pressure is expressed in atmosphere units. When gases are compressed using high pressure, the molecules come closer and get converted into liquid state. At this time, the kinetic energy of molecules decreases. This process is called liquefaction of gases. See the situations where liquefied gases are used. Petroleum gas is stored as liquid in cooking gas cylinder. Liquefied ammonia is used to hinder the hardening of rubber latex. Natural gas is liquefied and used as fuel. The pressure increases when gas from big cylinder is transferred to small cylinder at constant temperature. The volume of gas also decreases along with increase in pressure. Fill a syringe with air and close its nozzle. Now apply pressure on piston. We can see that volume decreases with the increase in pressure. Through some experiments, Robert Boyle established the relation between pressure and volume of gases. According to Boyle's law, the volume of a fixed mass of gas is inversely proportional to pressure at constant temperature. Mathematically, V is directly proportional to 1 by P. V equals a constant into 1 by P. Therefore, PV equals a constant. At P1 pressure, the volume is V1, and at P2 pressure, the volume is V2. Then P1 V1 equals P2 V2. From the table below, we can understand that PV is a constant. See the change in volume when pressure increases. When the balloon, which are used for studying climate changes, rise higher up from the sea level, their volume increases. We can explain this using Boyle's law. As height increases, pressure decreases, hence volume increases. This is the reason for the increase in the size of balloons. Dip an inverted small bottle into the water taken in a beaker and clamp it. Heat the beaker. On heating, we can see bubbles coming from the bottle. From this, we can understand that as temperature increases, the volume of gas also increases. Let us see why volume of gas increases on heating. On heating, the molecules gain kinetic energy, allowing them to move faster and further away from each other, which means that volume of gas is increased. When the temperature is reduced, we can see that volume is also reduced. See the graph. The lowest temperature attainable by a gas is -273 degrees Celsius. Assuming this lowest temperature as zero, or absolute temperature, Lord Kelvin introduced a new scale of temperature. This is called Kelvin Scale, and the symbol used is K. In order to get temperature in Kelvin scale, add 273 to the temperature in Celsius scale. That is, Tk equals T degrees Celsius plus 273. The law which relates volume and temperature of gas is called Charles' law. According to Charles' law, at constant pressure, the volume of a fixed mass of gas is directly proportional to the temperature in Kelvin scale. V is directly proportional to T. V equals a constant into T. V by T equals a constant. Let T1 and V1 be the initial temperature and volume, and let T2 and V2 be the final temperature and volume. Then, according to Charles' law, V1 by T1 equals V2 by T2. The equation which combines both Boyle's law and Charles' law is called combined gas equation. According to Boyle's law, V is directly proportional to 1 by P. According to Charles' law, V is directly proportional to T. By combining these two laws, we get V is directly proportional to 1 by P into T. V equals a constant into 1 by P into T. Therefore, PV by T equals a constant. If the pressure, volume and temperature of a fixed mass of gas are changed from P1 V1 and T1 to P2 V2 and T2 respectively, P1 V1 by T1 equals P2 V2 by T2. This equation is known as combined gas equation. Let us see the way we can increase the volume of a gas. Decrease the pressure. Increase the temperature. At constant pressure and temperature, the volume of gas is directly proportional to number of molecules. This is known as Avogadro's law. V is directly proportional to N. V equals a constant into N. V by N equals a constant. Avogadro's law can also be stated as equal volume of gases under the same condition of temperature and pressure contains same number of molecules. Let us see some examples of gas laws in practical life. Bottles filled with soda are kept under water in summer. This is because as atmospheric temperature increases, the carbon dioxide in soda expands, which leads to explosion of bottles. So in order to avoid such accidents, soda bottles are kept in water during summer. In summer, motor tires are filled with air at a lower pressure compared to that in winter. During summer, atmospheric temperature is high. According to Charles' law, volume also increases with increase in temperature. So if pressure inside the tire is high, as temperature increases, there is a chance for the expansion of tire material and hence causes the breaking of tire. So in order to avoid the tearing of tire, in summer season, the tires are only filled with air at lower pressure. The early studies and experiments on the gaseous state are important and interesting. It was towards the end of the 18th century that many of the mysteries and doubts regarding these gases came to rest. The chemists living in those times have contributed a lot for this.